And this is video number 30, a comparison of simple and compound interest. Now, I wrote this as being borrowed, but it could have just easily been investment. Anyway, let's do this. So my principal, 6%, paid back in 4 years. How much will be owed if simple interest in calculated? So A, P, I, N. So N is 4 years. Now, just because I'm going to do that, you don't need to do it on simple interest, but it won't hurt, right? So rather than going, when do I use it, when do I don't use the adjustments for the time, do it all the time. Then you never have to make that big decision. So it's 6 divided by 100 divided by 1, 0.06. Remember, simple interest is always per year. Always, always, always. And it is $3,500. And we don't know what I owe at the end. All I know is better be bigger than 3,500 now. A is equal to P plus P, oopsies, N. Remember, we're talking about simple interest, so we're going back to this formula. 3,500, which is the initial, plus times interest, which is 0.06 times 4 years. Does not that make sense, right? This is the interest per year. So we're going to put that 4 times over. Oopsie. 3,500 times 0.06 times 4. 840 is equal to 4,340. There we go. There's my simple interest. Now, what is going to change if I compound annually? I don't know. Let's see. A, P, I, N. Still 4 years times annually. That's still going to be 4. 6% divided by 100 divided by 1. Still going to be 0.06. And if you're saying nothing changed in that part, you're exactly right. But do it anyway. 3,500. No. So the only thing that changes is your formula. 1 plus I, N. A is equal to my principal, 3,500. 1 plus 0.06 to the 4. 1.00. Nope. Add an extra 0 there. Watch. Seriously, that's where I make most of my mistakes in finance. Just update it again. Honestly, the nice part is usually if you screw up by adding a 0 or leaving 1 out, your answers become so ridiculous you'll catch it right away. So like if I put that extra 0 in there, I'd maybe have a total of, I don't know, but it'd be just ridiculous answer so you can catch yourself. Put that where it's supposed to sit. Just gonna get my workspace set up again. 1.06 to, whoopsies. I know that number. I know that's 4. It's not an N. To the 4 times 3,500. So, because I'm curious, not that it's Oh, wait a minute. I did forget. It says how much interest do we get? Right, this is our interest rate. So on this one, 35, no, do it right. I'll put interest. We had 4340 minus 35,000, 3,500, 40. I cheated. I know the interest on these questions is right there. On this one, we end up with 4418.67 minus 3,500. 4418.67 minus 3,500. 918.67. So, well, you know what? Minus 840. Made an extra $76, or sorry, $78. Looks like that's in the glare there. That's cool, right? So exactly the same 4 years. Everything else is the same, but compounding annually, got an extra 78 bucks there. Now let's see how much difference there's going to be if we compound monthly. My brain says that there should be some difference. I don't know how much, because that means every month I'm adding in some interest to make my principal bigger. But that amount's going to be pretty teeny, so I don't know how much of a difference it's going to make. A-P-I-N. So now we got 4 years, but compounding monthly, so we need to go times 12. It's going to be 48. So my interest is 6 divided by 100 divided by 12. 0.005. So even though this goes up, the interest per time period goes down. So it's kind of like, which one's going to be more powerful? And our original investment is still the $3,500. Plus 0.005, right from there. And then it's going to be 48 this time. 1.005 to the 48. So I have that on my calculator. I'm just going to add 1. And I'm going to do power 48. And A is equal to 3,500. 1.2704 times 3,500. So 4446.71. So I'm going to do my interest right away. 4446.71 minus 3,500. Let's see, 71. So I'm going to just subtract 918.7. So 26 bucks more if you compound it monthly as opposed to compounding it annually. Now that's not very exciting, but the more money you have in there or the longer it sits, the bigger that differential is going to be. Now, what is the difference between the return on investment for the simple interest and the compounded monthly? I'm going to do it, but that being said, if we're looking for return on investment, we probably should have made an investment, not a borrow, but it's okay. We'll do it anyway. ROI. So is equal to interest over investment times 100. So for simple, we got, you can't see it, we had $840, and our original was 3,500 times 100, and monthly, I'm going to set them up first. I had 944.71 over 3,500 times 100. Okay, I'm going to do that. And I just realized, my bad, you couldn't see that. And for some reason, I chose to do it at the very bottom of the page. I'm sorry. That should go there. And that's what I get for doing this on a Saturday morning. Yes, feel a little sympathy for me. I'm doing your work. I'm doing our work on a Saturday morning. All right, calculator in the view. There we go. 840 divided by 3,500 equals times 100. All right, that's 24%. And monthly, 944.71 divided by 3,500 is that times 100, 26.99. So I'm just going to say 27%. But, you know, really, we already knew that, because in general, compounding interest, either if you borrow, it's going to cost you more, or if you invest, it's going to make you more. And the more often you have compounding, the better. Okay. Now, this last part, which I was busy trying to miss, this is hugely important. When you're talking about simple interest and compound interest, there's only one payment, that's it. You leave it and it grows. One. Uno. Yeah, I was going to do it in Crete, or Soto, but I don't remember. Is it maybe? I don't know. Whatever one is. One payment, put it in there, leave it alone. So, for example, I taught in a regular high school for 1 year, and we had our Saskatchewan Teacher Federation pension. So at the end of the year, there was amount X in that account, and it's been sitting there for 25 years. One payment, it just grows. And it's not bad. It's a fair amount of money in there now. Not really. Not enough to retire on. But it was one payment and done. As opposed to it's not exactly pension, but from SIAT, I put in money every single account. Every single month goes into that account, so that when I eventually retired in, I don't know, 25 years or so from now, there'll be money in it, right? And the same thing with loans too, right? It's not like you take a loan from somebody, wait 8 years, and suddenly, boom, you pay it all off at once. You pay it monthly payments. And that's what we're going to look at next. If you're doing a savings account, it's called an annuity. And if you're doing a loan, well, it's called a loan. I'm going to show you the math for those. All right, pretty exciting. Watch the next one.